Is normal force always equal to gravitational force? This is another one of those questions that I can't just say yes, because it really depends. If we have a bucket of fish, okay, you're a fisherman and there's a big old bucket of fish, and I'm going to draw my oh so amazing drawings. Let's see. There's a fish. There's a fish. We have a bucket of fish, and it's just sitting there on its supporting surface. Well, in this case, we have gravitational force acting downward, and normal force from this supporting surface is pushing it upward. Well, in this particular case, yes, gravitational force will equal normal force, assuming, of course, that the bucket of fish is not accelerating at all, if acceleration is equal to 0. I can confirm that by doing a quick force summation. So if I sum the forces in the y direction, I see that normal force minus the force of gravity. Again, let me put my axis up there. I'm just going to use a standard axis where we're saying y positive is upward. So we know from Newton's second law that the sum of all forces in the y direction is equal to ma. Hi, ma. Mass times acceleration in the y direction. And if we know the total acceleration of this bucket is 0, the entire left side cancels out, letting us know that yes, indeed, in this case, normal force is equal to gravitational force. Well, let's say, for whatever reason, while you're working the docks, you need to go pick up that bucket of fish to bring it to a customer. Now let's say it's a very, very heavy bucket of fish. It only makes sense. Notice I'm drawing them blue because I didn't want you to think that they were goldfish, of course. Let's say that you have to go pick up this bucket of fish. Well, if you were to go pick up this bucket of fish, let's say, we'll make you purple. You are going to go pick up, we'll give you bangs because of course that's super cool to have bangs, as I said before. You're going to pick up the bucket of fish. Well, let's say that this bucket of fish is 800 newtons, okay? The bucket of fish is 800 newtons. So, but you only are able to pick up the bucket with 400 newtons. You're not strong enough to pick up 800 newtons. No offense, I don't even know you, but I'm guessing. Well, you could possibly pick up 800 newtons. I mean, yeah, sure. I couldn't, but maybe you could. But in this case, you have the force of gravity, and we said that the weight of the bucket, we're just guesstimating, not guesstimating, we're making it up that it's 800 newtons. And we're saying that you are applying an upward force of 400 newtons. Let's take a look at this situation. Now, the bucket is still not moving. You're still not accelerating that bucket because you're not strong enough. You have to have your buddy come over and help you. But we have gravity's pulling down on the bucket. The floor or the docks are still pushing upward on the bucket. And in addition to that upward force, there's also your applied force pulling up on the bucket. Well, in this case, the normal force isn't equal to the gravity force because you're pulling some of the weight up off of the dock. So the dock doesn't have to push back with the full weight. It doesn't have to push back with what the full weight is of that bucket of fish. So in this case, you have the positive normal force acting upward. You have the positive applied force and the negative force of gravity. Well, Newton's first law told us that the sum of all these forces is going to be equal to mass times the acceleration in the y direction. That's ma. Hi, ma. And you have the normal force. You have the applied force, and we arbitrarily gave that applied force a value of 400. We arbitrarily gave the gravitational force a value of 800. We're still not accelerating the bucket because we're just simply not strong enough. And we see here, as we simplify, that our normal force is going to be equal to 400 newtons. Yet our gravitational force was 800 newtons. So in this particular case, normal force and gravitational force are not equal to one another. So let's go ahead and answer our question. The question was, is gravitational force and normal force always equal each other? No. Gravitational force equals normal force if the object is not accelerating and Fg, the gravitational force, and the normal force are the only vertical, or oftentimes we'll just say y, forces. Okay, so only if, and to be sure, of course, you should always do a free body diagram. Make it a great day.